Hello everyone, welcome back to the channel Unknown Physicist. So today we are going to look into a video about free body diagram. So why do we need this free body diagram? So this helps us to solve any problems which is based on Newton's law of motion, especially second law of motion. It really simplifies the problems and helps us to get the answers in a more easier way. Okay, so in which way this free body diagram is going to help me? So for example, let me consider like there is a table. I have kept a book on the table. I'm just going to push the book to the corner of the table. But we know the only force what we are applying here, this F only we know. But apart from that, there are certain other forces which is experienced by this object. So in order to know all those forces, we use this free body diagram. So basically I can say it as like it represents all the forces experienced by the object. Okay, so to draw a free body diagram we need to know certain things. What are they? So first step is we have to decide the system. So for which system we are going to draw a free body diagram, and second we have to identify the forces, not a particular force. There will be different types of forces, so we have to locate all those forces in the free body diagram, and next like we have to put arrow marks and represent those forces, and finally we have to write the equation to solve a problem. So these 4 steps are the most essential things that you need for a free body diagram. So let me start with a very basic example. So all the problems it will be pre-solved by me, but I will be explaining to you over here. So if you look over here, like I am having a 5 kg mass which is resting on a surface, right? And like it is experiencing an acceleration of 3 meter per second square. So now I have to what is the question over here? I have to find what is the value of normal force. You need to know what is normal force and what is tension. If you are not aware of it, like I have a voice note in my Telegram group for that. The Telegram group name is Unknown Physicist, as well as you can check the link of the group in description. You can find it over there. So I have to find what is the value of normal force. So first let me construct a free body diagram. So I have just taken a block and 5 kg I have marked it. So this we always know like normal force is nothing but which is acting perpendicular to our object. So the normal force is in the upward direction, and similar way there is a gravitational force mg, it is in the downward direction. So we need to find the normal force, right? We know that like the net force is equal to ma. So here what are the net force experienced? One is the normal force and the other is the mg. So if you look here, the force in the upward direction is larger than mg, right? So my equation will be n minus mg is equal to ma. So I am considering the value of g over here as 10 meter per second. Okay, 10 meter per second square. So then it will be n minus my mass is 5 into 10 is equal to 5 into 3. So which is nothing but n minus 50 is equal to 15. So my value of normal force is nothing but 65 Newton. So this is like a very simple problem. We will see a little step higher problem in this now. So if you look into this problem, you can see 2 masses. One is of 3 kg and the other is of 2 kg. So I am applying a force of 20 Newton. Okay. So here the question is we are supposed to find the acceleration of each block and the normal force between the block. Okay. So for this case, first let me find what is the acceleration of each block. So here I am going to consider it as a whole system to find the acceleration. So what it will be apparently, so my masses will be m1 plus m2. So my m1 is 3 kg and my m2 is 2 kg. So 3 plus 2 it will be 5. So my acceleration is 4 meter per second square. Next I am supposed to find the normal force between the block. How does this normal force exist? Let us discuss now. So if we take the free body diagram separately for each block, let me consider for the case of 3 kg. Okay. So here we know there will be a gravitational force downward which is mg, and there is a normal force which is acting upward. So I am applying a 20 Newton force in this direction. So what happens, this 2 kg block, right, it opposes and it applies a normal on this 3 kg block. I am repeating it again. This 2 kg mass opposes and it applies a normal force on this 3 kg mass. Okay. In a similar way, this 3 kg, like when this is applied, this is going to oppose a normal force over the 2 kg mass. Oh, hope you understood this is how it works. So it's basically a kind of action reaction pair, right, on 2 different bodies. So Newton's third law comes over here. So it occurs on 2 different bodies. So action reaction takes place here. So there will be a normal force this way and there is a normal force this way for the 2 kg mass. Okay. And also like in this particular problem we are not going to consider the y direction. we are not going to calculate or consider any of the y direction because our forces are applied in the x direction, right? So I will be taking for those only. So here we are supposed to find the normal force, right? You can either start doing with a 3 kg block or also 2 kg block. I have done for both the cases. So here this is for a 3 kg block. With the help of 3 kg free body diagram, I have written the equation. So it is 20 Newton minus N, okay, 20 N minus N is equal to MA, right? F is equal to MA, our formula. So what is the mass? It is 3 and our acceleration is 4. So N will be equal to 20 minus 12. So your normal force is 8 Newton. Other simple way, with the help of this block also you can do, which is N is equal to MA. So N is equal to, we know what is our M, which is 2 kg, and our acceleration is 4, so it is 8 Newton. Hope you understood. Like this won't happen overnight. You need to have a practice over few problems, then only you can get a good catch of it. Let us see the next problem. Okay, so this is like little bit higher version. So what is here? Here we are having 3 different blocks. One is of 2 kg, other is of 3 kg, and the other is of 4 kg mass, and they are connected by 2 strings. So let this be string 1 and let this be string 2. Okay, so here our question is to find the acceleration of each block as well as the tension in string. There are not one string, there are 2 strings, so it should be, we have to find T1 and T2. Okay, so first let me find the acceleration of the system. So I am going to consider like acceleration of each block. So I am going to consider this as a whole system. So F is equal to m1 plus m2 plus m3, so which will be 2 plus 3 plus 4, so it will be 9a, and the force applied over here, it is 18 Newton. So my acceleration is 2 meter per second square. Well, fine. Now we have to find T1, T2 separately. So what I am going to do is I am going to draw a free body diagram for each of the blocks. So let me consider for a case of 2 kg. So here look into the figure, like your question, this figure. So there is a force acting this way, right? So what happens? This 4 kg will oppose a force on 3 kg. In a similar way, 3 kg will oppose on 4 kg, right? Also over here, this 3 kg will oppose on 2 kg, and this 2 kg is going to oppose on 3 kg. So for the 2 kg, there is a tension force in this direction, that is to your right. So this, let me have taken it as T1. And similarly for a 3 kg mass, there is a opposition force acting on 2 kg as well as on 3 kg. So T1 and T2. And for the 4 kg, if you look here, there is this force of 18 Newton acting in your right, and as well as there is a T2 tension 2 in the string, right? So which is T2. Okay, so this is how the free body diagram helps us to solve the problem more easier. Okay. So with the help of calculations, like you can just look into the values. I am not explaining much over here. So if you just look into the values, I have substituted and I have found T1 and T2. And also over here, I have not considered the forces, that is the gravitational or normal force, because like our force is acting in this direction, like in the x direction, not in the y direction. Okay, so this is the other version. And finally we will see one more problem. Okay, so this is kind of similar to taking a pendulum or a Atwood machine, something similar to that. So there are 2 masses which is hanging on a pulley. The masses are 3 kg and 5 kg. Also they have mentioned it is a massless pulley and it is a frictionless string. Okay, so you have to look for these terms in your questions. If it is going to be a pulley which has some mass, then the question differs a lot, which we will be seeing in like higher problems later, not now. So these are the 2 words which you have to look into your question whenever like there is a pulley or a simple pendulum based question appears. Okay, so here also we are supposed to find the acceleration tension. So over here, like I am taking my free body diagram for 5 kg and 3 kg mass. So there will be a 5g, that is mg mass acting in the gravitational force in the downward direction, and there is a tension in the string which is in the upward direction. Similarly for a 3 kg, right? Okay, here like we can't consider it as a whole system. We are going to take in terms of equation, solve the equation and get our acceleration and tension. Okay, so if you look here, this will be my first one, this will be my second one. So sorry, this will be my first one, this will be my second one. Okay, so from the first one, what will be my equation? 5g minus t, because the force in the downward direction is greater than the force in the upward direction. So 5g minus t will be equal to 5a. Similarly over here, the force in upward direction will be greater than the force in downward direction. This is quite easy, you can relate. Look into the mass of these blocks. So they are quite like 5 kg is heavier, right? So you have to consider these factors while writing the equation. So I have got my 2 equations. So when you are going to add your 2 equations and simplify, you will be getting your acceleration. And also over here I am taking my gravitation value as 10 meter per second. So find your acceleration as 5 meter per second square. So once you have find your acceleration, it's quite easy. You can just substitute these in your equation and you can get your acceleration. So finally I've got my acceleration as 37.5 Newton. Okay, so this is how we basically use free body diagrams. So I'm going to give you few tasks which you can try. Let me say them. So over here, if you look, I have given you 3 tasks. Here like the problems are not any value based. You have to express in terms of these alphabets like A, T1, T2, M1, M2. So it will be a practice for you. Maybe when you are doing in exams, once you look into this question, you can do it directly. So it will be helpful for you. So just try solving these problems. No need to comment. You can also comment your answers, or else you can put your answers in the Telegram group, which is Unknown Physicist. So if you have any further doubts, feel free to message me. Sure, I'll be happy to help you. And also like thank you for watching the video. If you feel this video is going to help if any of your friends' preparation, please do share the video with them. Bye bye everyone. Have a good day.